the code, that is very difficult to get this without having the debugging symbols, correct? So we will be able to see the instruction level point where you have this, but if you want to get the line number with the C code, you should have the debugging symbols built into your program. Got it?
Can we write your own program to read the code file?
No, once if you don't have any debugging symbols built into the application, the executable files, it is very difficult to write to decode it back. That is impossible most of the times. That is, you should no one does it most of the times. The people will try to learn the assembly program, then they will try to understand what is happening. Clear? But first thing is, you are trying to access an environment. It is very simple case to find out it, right? You are trying to access that particular memory. You'll be able to find out which variable has this thing. But decoding it back with the assembly code instructions, it is very difficult. Clear? So why I have shown this thing, right? Because once you have shipped your program to the customer, they will not have the debugging symbols in that particular image. Clear? So in such case, then you need to go to this binary level debugging kind of thing. That's what we have done, right? This info registers, whatever I have shown you. But if you have this debugging symbols, you have stored it somewhere, right? So you can use those debugging symbols. You will be able to easily find out the problem as well. So let me show you that thing as well. Now I have this binary level debugger. So I'll quit it from this thing. This time what I do now, I will compile my program with the debugging information. So you know, right, -gcc-z command. So this will tell the GCC compiler that you have to put some debugging symbols into the executable file, so that any debugger can decode it, kind of thing. Clear? So how this debugging symbol data has to be put into this executable file also will be decided by the one format, there is a format called dwarf. So this format will tell you how this debugging information has to be stored into the executable file. So in our case, what I do, I will use this -g flag. I will try to recompile my old program with this G program. Clear? So now once I have this executable file, you can use this object dump -h sftp, right? This is executable file. Now when I give this thing, it shows that there are some extra sections here. You can see here. So there are some debugging arranges, debugging info, debugging line. These all sections contain some information that the GDB, any source level debugger, can use to decode the lines of the source code and to get the all local variables information as well. Clear? So now I know that my source file, my executable file contains this debugging information. Now what I can do, right? Let me run the same program once again. Let me run the same program. Let me pass something here to this thing. So this time I should be able to get the once again core file. So there is a core file once again. Now let me use this time GDB core. GDB followed executable file followed by the core file. So when I do this thing, so now you look at this output, it is very clear, right? So it says that it is the problem is in the my string comparison at the line number 18. The instruction is also being shown here. You can see this thing, the source code of it, and it says that my string comparison is taking to address as 0, from address as this thing as well. So it is now very clear that the problem is in this thing. So you can even list the function program. Now you can see it here. List is to show the program. Now you can say that the problem is at the 18th line. So this is where a write is happening. You are writing into to address, from address, from. So what happens? To address contains, now you can see the address here 0. You are trying to write into the 0th location. Then the problem comes. So now you can even still use the where. Now this time, previously these all information was not there, right? Now you can see it is very simple. It shows that these are the parameters given to this function. The connect has got these parameters and everything is shown here. And now it is very simple to map with the actual code and variables parameters to the your program. So and now currently we are at this, as I told you, we are at the 0th frame level. You can use info locals. I think it shows you the what was the value of the local variable. In my program you can see there is a local variable, what is it, save, right? So now it contains what, 0. That's what they say. And even there is another command, info args. It says that what were the parameters given to that function. Though they are here, we can use again this extra command, info args. When I say this thing, 2 is 0, from is this thing. So this time you need not to see the all registers, and you need not to see the code, assembly code, disassemble where the problem is. Everything is clear when you have the debugging symbols. Clear? So and you can even print the, what is it, the info. There is a function variables. It shows you what are the all variables that are there in your program, global variables, right? You can see these are the all variables that I have. So in our program, what are they? We have the uname, right? All variable names are there here, global variables. So we have, what is it, uname user, right? Where is it? So here there is a character, there is a pass, username, everything is here. Clear? This way. And as the all other commands as well, register, info registers also will work here. Clear? So any doubts here? So once your program has the debugging symbols, so debugging the program is very simple. So but if you don't have the debugging symbol, as I told you, you have to disassemble the program, and you have to see how you can map these binary level instructions with the source level instructions. So that is somewhat a difficult task, but that's what the choice you have. Once you have shipped the your program to the customer, there is no way you can get the debugging symbols. Clear? So any doubts how we use the GDB to decode this particular core file? So as I told you, right, while you use the GDB, you need not to pass the core file here. You can just say GDB the file name. So after you have loaded, there is another function called core file, command called core file in the GDB itself. You can say core file followed by the core file name. So this will also take that thing. So you need not to pass it through the command line as well, so that we can load the core file. So anything you are missing here? So as I told you, right, we have got this all information. What is this? Stack information and data segment, and this all information in the core file. There, but if you don't have the GDB and some kind of these kind of debugging tools, right? So sometimes you need to debug the you need to read the whole core file to understand what is there. Clear? So for that thing, as I told you, obj dump -h core file. When I say this thing, it shows you these all segments basically. So you need to write a program, or sometimes you need to use the already some existing binary tools to decode what the contents of this particular all sections. Clear? So to decode these things, you need to understand how these these all segments have been arranged in the core file. Clear? So for that thing, what I would suggest is, if you have the, what is it, source code, kernel source code. In my case, let me show you if there is a kernel source code with me. Best thing to learn how actually this all core file has been formatted, how it looks like. So if you, let's take any kernel you have. Let's say I have a latest kernel, 3.11 kernel. So here you have, there is a file called fs bin formats elf.c. So this is the file, actually this is a file which actually dumps the core of elf core file. Clear? So open this file here. So go to the end of this file. There is a elf format. Let me show you that function. This is the function. So there is a function called elf core dump. So this function will be called by the kernel whenever there is a problem, whenever there is a core dump has to be generated. So this is the function that has the responsibility to dump this all code. So you just I would say just go to this function and read this code. So this will explain you how this whole EL core file has been organized, what information it contains. Everything is explained here. That means with the code. So if you understand this thing, so you will be able to write your own tools to analyze this particular core files, or you will be able to use some existing binary tools to decode these all core file and to understand where the problem is. So this is best example, best exercise for you. Just go to this file, here you have it. Just go and read this file. This is very easy to understand as well. But before you read this thing, you try to understand the ELF specification. So there is a ELF specification. You can download it from the Google and read it, how it looks like, what the format of that file. So once you know that thing, you come here, you try to understand what information that is going to the core file. Clear? As I told you, all the other information, the previous layer that I explained, should go into the core file. So that will tell this function will tell how that information is encoded into that particular core file. Clear? So once you have got that information, I should be able to tell you that you can write one function, a piece of code to decode this core file. Clear? So in my case, I have written one code here. Clear? So just to show you how to decode a whole these sections of the core file using your own program. Clear? But I'm not going to explain you this code. This is, as I told you, right, you should be able to understand the ELF header, then only you will be ELF format, then you will be able to understand this code. So I opened this core file, whatever the core file that has been given. I have read these all sections or segments. I try to decode the minimum information that I require to find out the problem. Clear? So I'll give you this program so that you can analyze it, and what I have done you can understand it. So once you have this code, right, we can compile this code. Let's say core nodes -o. Let's say I give the command name cn. I'll again compile it with 32-bit. Now cn, the code, the command, followed by give any core file. Then once you press enter, right, it says you some information of it. So whatever the GDB information that we are getting,